So following on from the previous video, I'm now going to give you some examples. So suppose you're given f of x equals x squared. Find the antiderivative of this. So you finding the antiderivative is you trying to find a function that you trying to find this function here. When you differentiate it, it will give you x squared. So so to do this here, make a guess. Start out with a guess. Let's say x to the power 3, because when you differentiate x to the power 3, the power here gets minus by 1, giving you this. But the thing is, when you differentiate x to the power 3, it will give you 3x squared. But the thing is, you only want the coefficient to be 1, not 3. So you start out with your guess, and then you make this slight adjustment. So the slight adjustment in this case will be a third. So now if you try and differentiate this, if you differentiate this, this will go over here, giving you 3 times 1 divided by 3. The two 3's here will cancel each other out, giving you the 1. So basically, you would start out with your guess here, but the slight adjustment that you have to make is this a third here. So this here. So here, when you differentiate this, it will give you this x squared. Okay. But the thing is, when you differentiate this whole thing plus, let's say plus 3, then this will also give you this. If you try and differentiate this whole thing, let's say minus 7, then the whole thing here will also give you x squared. The whole thing, the point here is that you've got to take care of the whole family. So you got to put this constant here. You see, by you writing this plus c, no matter what constant you put into here, it will take care of it. It will differentiate to x squared. So overall, the answer here will be this. Okay, you do need this plus capital C here. Let me give you another example. What is the antiderivative of this? You see, it's you trying to come up with a function that when you differentiate this function, it will give you this. So start out with your guess. Looking at this one here, you would probably guess x to the power 3. Okay, and then looking at this one here, maybe guess x squared. Okay, so when you differentiate this here, it will give you 3x squared. You see, this here is good, this here is good, but you don't want the 3. You want this 4 here. So here you would start out with your x to the power 3, but adjust it. So if you do this here, hang on. If you do this here, if you make this adjustment, you see, if you differentiate this, it will give you this term here. So for example, 4 over 3 x to the power 3. When you differentiate this, the 3 goes over here. This becomes a 2, and then the two 3's here will cancel each other. Well, this here would be your first term. So whether f of x equals 4 over 3 x to the power 3. And then this one here, if you differentiate this, the 2 goes down here. The adjustment that you have to make here would be 3x squared, because when you differentiate this would multiply with this, giving you 6x. So the antiderivative here would be this, and then you've got to take out the whole family, so it's plus capital C. So this here is your antiderivative. Okay, when you differentiate this whole thing here, it will give you this. Okay, let me give you another example. So this one here, you got to try and finding the antiderivative of this would be you trying to find out a function that when you differentiate it, it will give you this. So start out with our guess for this one here. If you start out with cos of x, when you differentiate cos of x, it will give you minus sine of x here. But you don't want a minus in front of here. So adjust it. Okay, let's guess minus cos of x. So when you differentiate minus cos of x, it will give you positive sine of x. So in this case, now the antiderivative will be, well, in order to create this here, we're going to guess this minus cos of x, minus cos of x. Okay, and then here, what differentiates to a 4? Well, we're going to guess, well, it's going to be 4x. Okay, when you differentiate 4x, it will give you 4. So this part here will be this 4x. Okay, but then if you think about it, the whole thing here, if you plus a constant, let's say 7, this whole thing here will also differentiate to this whole thing here. But the point is, you got to put the plus c in here. This plus c is important. It really encapsulates the whole family of these curves here that will differentiate to this. So you do need the c here. So the antiderivative is given by this. Okay.